Hello, this is Ms. DB, and in this video I'm going to show you how to do some of the problems from the Chapter 5, Section 8 assignment. We're going to start some trigonometry in this lesson, so it's going to be kind of fun. So we start with a 45, 45, 90 triangle. So it has to have a right angle, and in a right triangle that has two angles equal to 45 degrees, the two legs will be congruent, and the length of the hypotenuse will be the length of a leg times the square root of 2. Now you could find this out by doing the Pythagorean theorem. You could take 8 squared plus 8 squared and that would equal the hypotenuse squared, and that would be 64 plus 64, or 128. And 128 is equal to, of course, 64 times 2. So when I take the square root of both sides, I would have the square root of 64 times the square root of 2, and the square root of 64 is 8, so we'd have 8 square root of 2 is equal to c. And that's exactly what this theorem says, is that this is, as many theorems are, it's a shortcut. You can just take the length of the leg times the square root of 2, and that will equal the hypotenuse. Now sometimes they give you the hypotenuse and you're supposed to find the length of a leg. So then you would divide by the square root of 2 to find the length of one of the legs. So here's the actual theorem here, written here. You can see that they use L for one of the leg lengths, and they multiply that by the square root of 2 to get the hypotenuse. Now when you do these problems on your own, some of them you are given the length of a leg, and you will just need to multiply by the square root of 2. You can type SQRT for square root of 2, or you can go to Insert, and there is a square root symbol right here. It's not perfect because it doesn't have a line across the top like a real square root would. Let me show you what it would look like. So if I wanted to write the answer here, it would look like square root of, whatever times the square root of 2. Come on, 2. There we go. So you still have to fill in what would be times the square root of 2. That's one way to do it, or like I said, you can just type SQRT for square root. There's also, if you really want to get into this, there is equations on the newer versions of Word. So you can go to the equation editor, and they have a square root which would look like the real square root with the bar all the way across the top of it. But not all of you have that version of Word that has that in there, and even if you do, it might take longer to make it than it's worth. Now I want to look at one where you are given the hypotenuse and have to find the leg, like number 3. So in number 3, we are given that we know it's a 45-45 triangle because x and x are the legs, and they're equal to each other because x equals x. So to find the leg, you're going to work backwards. So I know the theorem says that if I have L, I would multiply by the square root of 2 to get the hypotenuse. And I just know that L is x, and I know the hypotenuse is 8. So I'm solving this, I will be dividing both sides by the square root of 2. Now, if x equals 8 times the square root of 2, you can't leave it like that. Having a radical, a square root in the denominator is considered not simplified. So I need to multiply both top and bottom by the square root of 2. This is called rationalizing the denominator, kind of a long name for what we're doing. Now here's why this works. When I multiply square root of 2 over square root of 2, that's a form of 1, so that's allowed. You can do that. So on the top I have 8 times the square root of 2. Now in the denominator I have the square root of 2 times the square root of 2. Well, the square root of 2 times the square root of 2 is square root of 4. The square root of 4 is just 2. Now you simplify the 8 over 2 part. the numbers in front of the radical. 8 over 2 is the same as 4, or 4 over 1, but you don't need the over 1 part. So this all simplifies to 4 times the square root of 2. So that, again, when you have the denominator with a radical in it, with the square root in it, you multiply both top and bottom by that square root, and that rationalizes it. That's a form of simplifying roots. This one you won't have to do hardly anything to, because you have that x times the square root of 2 is equal to 25 times the square root of 2. So you just need to divide both sides by the square root of 2, and when you do that, the square roots of 2 cancel, and you're just left with x equals 25. So sometimes the square root will cancel like that. Okay, and then we're going to look at a 30, 60, 90 triangle. That refers to the angle. So we have a 30-degree angle, a 60-degree angle, and a right angle. All 30, 60, 90 triangles are similar to each other, so they have developed this shortcut theorem to how to find the lengths of the legs and the hypotenuse if you know one of them. You only have to know one and you can find all of them. Whereas in the Pythagorean theorem, you have to find two to find one. So here is the shortcut theorem. And down below I wrote really what this means. If you know the short leg, which they call S in this picture, if you multiply it by 2, you'll get the length of the hypotenuse. If you know the short leg and multiply it by the square root of 3, you'll get the length of the long leg. And you can use these two little equations to find the length of any of the sides if you know one of them. So here we have this triangle here. We don't know either of the legs, but we do know the hypotenuse. So I wrote what you should start with. You should start with the equation short leg times 2 equals the hypotenuse. And the short leg is x, so 2 times x would equal the hypotenuse is 18. Remember that the hypotenuse is always opposite the right angle, not touching the right angle. So then you can solve that for the short leg. Once you know the short leg, then it's easy to find the long leg. You just multiply that number by the square root of 3. And leave your radicals in radical form. Don't change that to a decimal. We want simplified radicals here, not decimal. Okay, let's look at number 6 is going to be easy because they give us the short leg to start with. So we're just going to be able to take the short leg times 2 to get the hypotenuse, and the short leg times the square root of 3 to get the long leg. And for the long leg, I would just leave this as 2 times the square root of x for the long leg. 2 times the square root of 3. All right, let's look at one that looks trickier. This one looks a little trickier because they give us the long leg. So in number 8, we are going to find the length of the short leg first. They don't give it to us at all. But I do know that the short leg times the square root of 3 equals the long leg. So the short leg is x. And the short leg times the square root of 3 is going to equal the long leg, which they tell me is 33. So to solve this, I need to divide both sides by the square root of 3. I can't leave my answer like that because that's considered not simplified. So I need to rationalize the denominator again. And you do that by multiplying numerator and denominator by square root of 3 over square root of 3. So then on the top, in the numerator, I get square root of 3 times 33, 33 times square root of 3. In the denominator, I have the square root of 3 times the square root of 3, which is just 3. If you want, you can figure out that it's the square root of 3 times square root of 3 is square root of 9, but the square root of 9 is 3. And then we simplify because 33 divided by 3 is just 11. So this is the short leg. Once you know the short leg, we follow the rules to find the hypotenuse. And to find the hypotenuse, we take the short leg and we multiply it by 2 to get the hypotenuse. And our hypotenuse is y, so I guess I should have wrote y there. So to multiply this times 2, you only multiply the number of parts in front. Whoops, the whole number of parts in front. Where did it go? Here we go. So 11 times 2 is 22, so you'd have 22 square root of 3 is your answer for y. And again, you don't want decimals for these. You leave it like that, 22 square root of 3. And then there's some problems at the end where you will be finding the missing side of each figure. It's helpful to draw a picture. And on these ones, you are going to round to 2 decimal places, or you can leave as, why does it keep jumping around? Or you can leave as simplified radical. I know the directions say 2 places, but I'm going to say either one. So again, a picture helps because there's no pictures for these. So a 45, 45, 90 triangle means a right triangle where the 2 legs are congruent, and these are 45. And the hypotenuse is given to us as 12, and you have to find the length of a leg. So to find the length of a leg, remember that the shortcut theorem says that if you take one leg and multiply by the square root of 2, you get the hypotenuse. So we can see that we need to divide by the square root of 2, and when we do that, we would have to rationalize the denominator. Now, since you were told that you could leave this in as decimal form, you could take 12 and divide it by the square root of 2 on your calculator and get a decimal, if that's what you want to do. Or you can practice simplifying your radicals more and do it that way. So we get 6 times the square root of 2. And then let's look at another one. Now, number 11 says a square with diagonal length of 18 meters. Let's just look at a picture of what that means. That means we have a square, which of course has all right angles, and we are going to divide that square with a diagonal, and this is 18. So what we have really is 2 right triangles here, and they're each 45, 45, 90 triangles. So if I'm looking for a length of leg, we really have, very similar to the one we just did, and you'll have to divide by the square root of 2 to get your answer. Okay, and then we have some other problems down here, and on these ones the picture has been drawn for you. You have an equilateral triangle, so this side DE would also be congruent to DG and EG, but it was hard to draw that without putting a mark right on the, and then it was divided into 2 right triangles, and you're supposed to find all of the sides. So we know only that this is 4. Each side is equal to 4, and your job is to find the hypotenuse, which would be here, and the long leg, which would be here, and the short leg, which would be here. So one of those is already given to you, and then you'll need to find the other, well, really 2 of them you can find quickly, and then there's only going to be one that's going to be a little bit hard to find. And then this is similar, except this time the height is given to us as 30, and then you're going to find the other parts of the triangle. You need to find the hypotenuse, the short leg, and then this is the long leg. All right, if you have any questions on this, let me know, and we will continue to use these for the rest of the year, so do pay attention to these theorems, and it'll save you a lot of time in the long run if you learn these shortcut theorems. Thank you very much and have a wonderful day.